Hi, my name is Dr. Christopher Kavanau, and today we're going to learn about the basic definitions of the trigonometric functions. And one classic way of defining the trigonometric functions is in terms of the unit circle. So a unit circle is just simply a circle of radius 1 centered at the origin. And so here I have drawn one. And you should know that the equation for a circle is x squared plus y squared is equal to the radius of the circle squared. And because the radius of the circle in this case is 1, then it's going to be equal to 1 squared, which is 1. So our equation then is just simply x squared plus y squared is equal to 1. So one way of defining angles in trigonometry is in terms of the arc length subtended by the angle. So here we have an angle theta, and here we have a radius vector extending from the origin of this unit circle to this point on the unit circle. And that defines an arc length, as you can see here, which I'm representing by the letter S. All right? Now, in trigonometry, one way of defining these angles, an alternate technique than using the degree measure, is using radian measure. And in radians, the angle is just simply equal to the arc length subtended by the angle on the unit circle. Okay? So then, let's look at an example. Supposing we wanted to find out what 180 degrees is in radian measure. Okay? Well, we know that the circumference of a circle is defined to be 2 pi times the radius of the circle. And because the radius of the circle is 1, the circumference is just simply 2 pi. Well, 2 pi would be going completely around. That would be the arc length around the entire circle. But 180 degrees, that would be going around halfway around the circle. So halfway would be half of 2 pi, which is pi. So therefore, the arc length extending from here all the way around to the other side would be pi. So therefore, pi radians is equal to 180 degrees. Okay? And similarly, we could look at other examples too, like for example, a 90-degree angle. That would be 1/4 the circumference of a circle, which would be 2 pi divided by 4, and that's equal to pi over 2. Okay? Now, in trigonometry, we can define the trigonometric functions, cosine and sine, as being the x and y coordinates, respectively, of the point subtended by an angle theta measured in radians on the unit circle. So, for example, this point here, the x-coordinate would be cosine theta, and the y-coordinate would be sine of theta. And so then we could take an example if we wanted to take, say, for example, the cosine of pi radians and the sine of pi radians. The cosine of pi radians, well, that's going to be the x-coordinate of this point here. All right, so that's going to be -1. And the sine of pi radians, that's going to be the y-coordinate, which is 0. Okay, so that's our first introduction.